Welcome to a flight test briefing for the Albatross aircraft in Unity. The first test carried out for the UAV is determining the CG position and mass, which is calculated using wheel reaction measurements, using the port, starboard and nose arms with their respective loads. The aft CG limit was found to be 0.12 meters for wheels down. We can see the measured CG against the actual CG for different locations, and it shows a linear trend. In the thrust test, the Albatross's thrust was put to maximum, which can be seen as 28 newtons. As seen, the thrust increases linearly with RPM. The aircraft's control inputs are configured to ensure that static response is correct, with the aileron, the elevator, the rudder and the flap configurations being changed when necessary. The pitching response is compared using changing wind speed and CG position. As seen, increasing wind speed increases the damping ratio, and the aircraft is more responsive to the elevator input and returns to the datum faster. Moving the CG further aft means that the aircraft gives a higher response, but will lose stability. The max aft value for the CG position was found to be 0.05 meters. The roll rate increases with wind speed, so there is a greater response as speed increases from the aircraft. The damping in yaw was found to be less than the damping in pitch due to both the rudder or the elevator. Moving the CG position down caused a pitch down moment, while moving the CG position upwards caused a pitch up moment for the aircraft, as can be seen. The vertical CG position for zero thrust pitch was found to be around minus 0.025 meters, with there being little pitch difference as thrust increases. The lift coefficient versus angle of attack was plotted for different flap settings, with the maximum flap value equaling 1.17 for lift coefficient, which was at an angle of attack of 7.78 degrees. Flap equals 40 degrees. Drag coefficient was also plotted against lift coefficient for clean configuration, with the maximum lift-to-drag ratio of 15.25 at a CD of 0.053 for a flap value of 40 degrees. This is significantly less than the manufacturer's value, which is between 28 and 30 to 1. Plotting CM versus CL for different elevator values shows that the best angle for trim is minus 15 degrees, due to there being no moment about the CG, therefore allowing the aircraft to be trimmed. Plotting CM versus CL for different CG positions shows that moving CG more aft decreases stability. As CL increases, CM should decrease, but this is flattening for an increase in CG position, therefore decreasing stability. The neutral point is estimated to be at around 50% Mach. Increasing ground taxi speed means that the aircraft is less stable and increases the chance of tipping when turning. Therefore, ground speed should be kept to a minimum for any kind of maneuvers. Further, When the aircraft is taking off, care must be taken when pitching, due to the tail hitting the ground. The minimum speed for the aircraft to take off with both the flaps deployed and not deployed was found to be around 18 meters per second for both. The cruise speed was trimmed at 30 rpm and at an elevator angle of 6 degrees. The phugoid frequency was found to be 0.267 Hz and the period was 3.75 seconds. The minimum trim speed was found to be 16 meters per second for 15 rpm. The maximum speed was found to be 44 meters per second for 100 rpm.